Hello everyone. Today we are going to discuss about intermediate code forms in compiler design. I'm Manogna from CSA department. Agenda is like introduction, benefits of intermediate code and different forms. So let us introduce the concept of intermediate code. Introduction is like the task of compiler is to convert the source program into machine program. Compilers generally represents the source program in an easy way, which we will call as intermediate code. As we can see in the diagram, intermediate code generation is like it will convert the complex program into easier way. Let us come to the benefits. Benefits are of 5 types. 5 benefits we have as per the note, but we have many, but we are taking the important ones. Easier to implement, facilitates code optimization, platform independence, code reuse, easier debugging. The first one, easier to implement, is like it can simplify the code generation process by reducing the complexity of the input code. The second one, facilitates code optimization, is like it can enable the use of various code optimization techniques, like it will uh, improve an efficiency of the improve and efficient of the code generator. Platform independence. Independent intermediate code is platform independent, so it is like it can be translated into machine code or bytecode for any platform. Code reuse. Intermediate code can be reused in the further in future to generate code for other platforms or languages. Easier debugging. Intermediate code can be easier to debug than machine code or bytecode, as it is close to the original source code. So the third one is like the forms. There are 3 types of forms, like abstract syntax tree, uh, polished notation or prefix, 3 address code. The first one, abstract syntax tree, is like it is also called as DAG, like that is directed acyclic graph. It is the abstract syntax tree is a very much similar to syntax tree, but are not more compact form. Like a syntax tree serves as a condensed representation of parse tree. As per the definition, let us see the example so that we can understand it clear. So let us take an example. X is equal to minus a into b plus minus a into b. So the syntax of the tree here in the example picture, the syntax tree is like x is equal to plus this form is like we already know that we are gonna split the graph according to the operators and the operands. Okay, so it is in this form. So now the DAG is like x is equal to plus. Plus means it is only taking the one part of this. Like we we are having the same operands. So by considering this, we are gonna having this like a minus b in a one form. Second one, polished notation or prefix, sorry. It is also known as reverse Polish notation or suffix notation. In the infix notation, the operator is placed between operands. For example, a plus b. Here we can see like the operator is placed between 2 operands. Postfix notation positions the operator at the right end, like that is here a b plus, it is placed right side of the operands. So for clearer understanding, let us consider an example. A plus b into c cap d minus e by f plus g. So here in the picture, this is a syntax tree we already drew for the previous form also. Now we are taking the uh, prefix notation, like here we wrote ABC x ABC into plus, like we are considering postfix not prefix, so we are drawing it in a postfix way. Here a plus cannot be placed between two, we are only considering post, right? So A, B, C will come first, and then we we don't know which one have to be, which one use which one we should take first. So the first one is like A, B, C. We have to write here. We have to take the first one, like which is the inner. We already see in the example question like A plus B into C, like B into C is the interior. So we are taking into first and S afterwards, and then after completion of this we're coming here D. There is nothing other operand is there, so we are directly keeping cap, and now we are not going to take this directly, so we are going to E F G again. Here you see, and then first we are taking plus, then division. See, first the inner one and the outer one, then afterwards total outer one, the minus. This is the form of postfix notation. And for that we are gonna taking for you know, not only with the we can also do a statement form. Let us take the statement like A plus B into C cap D minus E by F by G. We already took it. A plus, like we are taking B into C as T1, like we are reducing it from left to right. B into C as T1, A plus T1 as T2, D cap D, T2 cap D as T3, F plus G as T4, E by T5, T4 like T5, and T3 minus T5 as T6. Sorry if it's not visible. So it's like T3 minus T5 is stored in T6. So let us take the elements T1, T2, T3, T4, T5 and T3, T6. Here T1 is equal to B into C, right? As we took postfix, we are gonna write it as BC into T2 is like we took A plus T1. So we are gonna write A T1 plus. Like we are we are taking postfix. So we are gonna write in right side. For everything we are gonna write like this. So now we are gonna simplify it. Like let us take the last equation is like T3 T5 minus, right? So we are simplifying everything. Here, see this. T6 is simplified as T3 and T5 minus. Minus because T3 minus T5 minus, it will come postfix, right? The minus operator will come right side of the any element. So here we take T3 minus T3 T5 minus, and we are gonna like we are opening, like we are simplifying it. T3 we have T2D cap, T2D cap we are writing, and T5 E T4 divided by, so we are writing this, and we are gonna simplifying this T2 and T4 also. T2 is like A T1 plus, A T1 plus we have written, and here, oh sorry, here it is like T4. T4 is divided at FG plus, FG plus, and then T1, and here where, yeah, yes, everything is come. Here T1 is has to be simplified. T1 is like BC into. So we got the equation as we got in the tree form. So like that we have to simplify it. Address code is like address code, three address code form at most. uh, Three addresses are used to represent any statement. For example, A is equal to B plus C plus D. In order to represent this expression in three address code, we are using temporary address variable. Like here we see A is equal to B plus C plus D. T1, in T1 we are storing B plus C. In T2 we are storing T1 plus D. Like T1 is B plus C, right? So the b plus c is stored in t1, and in a we are storing a t2, like we are storing the whole sum. There are three types of t address code, that is quadruples, triples, and indirect triples. The first one, quadruples, is like in quadruple representation, the structure will have at most 4 fields such as OP, operator, argument 1, argument 2, result. So OP means operator. We already know that is plus minus into division equation equal to. Argument 1 is like one of the argument 2, and result is like the variable we are storing. So let us consider example, x is equal to minus a into b plus minus a into b. In t1 we are storing minus a, that is here minus a is there na, that we are storing here, and into t2 we are calculating t1 into b and storing it into t2. The same way follows to T3 and T4. The T2 will store this part of minus A into B, and T4 will store this part of minus A into B, and both are added in T5. Both are added and stored in T5, and T5 is stored in X. So this is, we have to represent in tabular form, like we already said, 4 fields. So 4 fields are like OP, argument 1, argument 2, result. In O, in 0 pointer, first operator minus operator, this minus word is also an operator because it is an operator. Minus argument A, argument 1 is A, we don't have any argument 2, so we are keeping it as empty, and we are storing these two in T1. In the next one pointer is like into. Here we are multiplying, like we have already stored t2 t1 into b in t2, like we have stored t2 t1 and b and into, like that we have to keep everything and assign it. We are storing it and we are taking the result, like that. Triples is like we have to avoid that result part, like in the previous slide we have this result thing, right? Now we are gonna avoid this result thing, and we are gonna take, like here we took t1, t3, t2, t5 and all. We are not gonna take in this form, like we are taking the pointers view. We are storing it in a pointer. So 0, 1, 2, 3, 4, 5 is the pointers. So we are gonna consider pointers. Minus a space, and this is stored in the 0 pointer, like that, into, and 0 pointer which is stored this as calculated and stored in 1 pointer, like that. This also stored in second point 2 pointer, and in 3 pointer we are calculating like this, and we are adding the 2 pointers 1 and 3, and we are storing the total result in fifth pointer, like that we have to do it. In the last indirect triples, we are in the last form, we have took the 0 point 0 1 2 3 pointers, right? But in this form we are replacing it, like in the previous form we took t1 t2 variables. Now in the indirect one also we are taking only this pointers in a different pointers, like for 0 we are taking 11, for 1 we are taking 12, and indirectly we are storing it, like we took it in a very different form, like that. Thank you.